Okay, so let's get back to the second session. Everybody, just take your seats and we will start in the next few seconds. Okay, here we go. Second session, second topic, a brave new world of artificial intelligence with Tomislav Tipuric. He is the CTO and partner in Nefos and a technology enthusiast with a focus on cloud computing, artificial intelligence, IoT, and modern business models. So he also previously worked for more than 30 years with Microsoft in various technology and strategic positions. And so please, a warm welcome on stage, Tomislav. Hi. So,
thank you, Josipa.
You're welcome. And the stage is yours. We will listen to your topic. And
you will. Thank you.
Thank you.
Thank you so much. So, guys, I wish you a warm welcome. We are finally, I would say, back in the live events. Personally, this is what I like about my job, to have a big event, a big crowd, interested in technology, and try to actually influence you to use that technology better. If you can take one or two advices from me today from the session, I would be glad, because that's my job, that's what I do. So thank you for joining me, and first we have a little video, a little reminder from the series that I'm sure you guys watched.
Maybe we should take a step back. Take a step back? I'm not a young man anymore. No, I mean, reevaluate what we're doing with the guidance system.
But I got a baby on the way. I gotta make some money.
What good is money gonna do if we inadvertently bring about Armageddon?
Okay, let me stop you right there. We absolutely know our invention will not be used to destroy the world.
How?
Because no one from the future has come back to kill us.
Very funny.
You got something better?
Oh, not really.
Okay, then.
All right, so basically, artificial intelligence, as regular people think of it, is something that Leonard and Harvard just actually explained. Oh, we're going to destroy the world. We're going to create something that's going to become uncontrollable. It's going to kill us, you know, like in Terminator, all those kinds of movies. But basically, what we in technology actually know is that any intelligence that we can observe amongst machines, which basically can mean software, in a wide term, is actually artificial intelligence. So anything, and artificial intelligence has been part of our lives for decades now. Maybe not that visible in our everyday life as it is in the past few years, but those things, those principles that we're going to talk about today are actually with us for quite some time. And you will see that there's only one thing that's different that actually created this whole world around us, this reality that we are now living in, that is called the new emergence of artificial intelligence, which we've been seeing for quite some time now. Basically, I like to go through the little history of the whole thing so that you can actually understand what we mean by artificial intelligence and why do I say that it's been with us for quite some time now. Turing test is one of the most important things when talking about the modern AI. Because Alan Turing is actually one of the founding fathers, as it said here on the slide, of the modern approach towards artificial intelligence. And its test is quite simple. So it basically means you need kind of three persons, or one person, one artificial intelligent machines, and a person to control it probably, and a judge, kind of. So basically, you will have starting conditions. There's an interviewer. That's a judge. That's a person asking questions. You have, in one room, an actual person. In the second room, artificial intelligence. Probably a person that's going to answer what AI answers. That's how it was thought of. And then the process is like this. Interviewer has a fixed amount of time to ask questions towards rooms A's and B's. If, after that amount of time passes, interviewer can't figure out in which room is an actual person and in which room is an artificial intelligence, we are saying that an AI has passed Turing test. And this whole thing got, I would say, blown out of proportion 4 years ago or 3.5 years ago when IT guys actually created an AI model that was able to write poetry. And it was said, this is huge, because this was the first model in decades that regular people couldn't figure out which poetry was written by an actual poet and which poetry was written by an AI. So that's when the Turing test actually came back into our lives and we were starting considering what it means. But if you look at AI versus humans, that story actually goes quite far. Back in 1997, Garry Kasparov lost first match towards AI. That's when this whole thing started. That's when, how is it called at that point in time, computers became smarter than people. Because a computer actually has beaten Garry Kasparov in chess. But it has continued then on. In 2011, Watson actually won in Jeopardy. So that was the first time that AI was smarter than humans in something which is not related to mathematics, which was huge at that point in time. And in 2016, Google's DeepMind actually won in Go, which is probably one of the most complex games in our world that we know of. This was 10 years earlier than expected. So we had expectations that this is going to happen, because that was the kind of the path we relied on, and that was what was happening in the world. But this was 10 years before we expected it. And that's when people got scared. That's when people said, all right, we'll need to put some set of rules. We'll need to create some kind of a method to actually control what is happening in the AI world. Because if this is possible, who knows what else is possible? And currently, in the current state, we are not yet there. The legislation is not yet there. The rules are not yet there. Each country is experimenting on its own. But you guys know what happened in the past 2.5 years. You guys been part of that world, of the pandemic world, where everything and every single process in basically every single country in the world became digitalized. The digital transformation, blah, 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 as the business people call it. But the effect of it is that everything now runs on software. And we are the ones who write that software. So if the whole world relies on software and we are the ones providing it, what that makes us? It makes us responsible. More than ever in the history of our industry. And if we need to be responsible for what we are doing, we probably need to have some kind of ethic codex. And this is the one that people from Saturdays.ai, from Barcelona, actually, a company, came with. AI Hippocratic Oath. You know what Hippocratic Oath is? That's something that medical doctors actually, are going through at the end of their college, that they are going to protect human life amongst all costs, blah, 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 blah. That's the same thing, just applied towards the job that we are doing. Because there are many, many bad things, and you will see some examples, I will show it to you, even from your industry, even from the automotive industry, where this would help. Bias is one typical example. Because there's a story from the US, actually, obviously, from the US. They were trying to create a smart hand washing system. So, typical hand washing system actually has just an infrared light there, and when you put your hands, you cross the infrared light, so it actually allows the water to go. They wanted to be smarter than that, so that you can't put any object, but you are actually washing your hands. And it worked quite well. Somebody from Norway, somebody from Croatia, where I'm from, actually, from Germany, from Austria, we were all coming in, and we were washing our hands quite fine. But then an African-American person came in, and the water didn't go. It was a horrible thing. It created all sorts of negative PR for the company. And what was the problem? Because the model itself was trained only on white people. Artificial intelligence didn't know how to recognize it. This kind of approach actually helps us to avoid those kinds of mistakes. Like in a general statistics, that we need to kind of create, a different sampling strategy. That's the same way we need to sample our training data for our models. We need to take care of all of the things. We just can't say, all right, there's 5 people here, I'm going to use them as the model, as the training data for the model. No. And this kind of approach actually helps us with it, because we need that kind of a codex in what we do. And I told you that I'm going to explain why this is happening right now, why this is happening in the past 6 years. And it's actually rooted in another reality. It has nothing to do with software. We as developers have a little bit better models, a little bit better algorithms, but not better enough to create this kind of revolution that has happened with the AI in the past 6 years. This is the Moore's Law. You probably heard about Moore's Law. Moore was one of the CEOs of Intel company. And he basically said, the amount of computing power that you can buy for some amount of money actually doubles every 2 years. So I bought my PC for, I don't know, 1,000 euros this year. In 2 years, for 1,000 euros, I'm going to be able to buy double the amount of computing power. So it's going to be twice as strong as my current PCs. And this is how the business people look at Moore's Law. This is from Wikipedia. But this picture gives you a false sense. Because in this picture, Moore's Law looks like it's linear. Nothing major happening there. However, if you look a little bit closer to the epsilon axis, you will see that it's a logarithmic. This is a true story of the Moore's Law. Just get back to the point where I was thinking about 2016, 6 years ago. So between 2010 and 2016, this is the jump in the computing power that happened. It's not linear, it's exponential. It's huge. And that's why something which was nearly impossible in 2010, for example, speech recognition. Speech recognition required specialized hardware, specialized systems, was used only somewhere in the American courts, to actually do that kind of transcription and those kinds of things. It was hard in English. And obviously, we all expected that it's going to get done some way for English, for German, for, Mandarin, for Italian, for French. In 2016, every people in my home country, in Croatia, had it in its own phone, whether it was Android or iPhone, the ability to recognize Croatian language, to speak, and the computer or the phone in itself would type what you speak in the language that's spoken by less than 4 million people. That's an amazing jump, enabled by hardware, which became cheaper, which became part of the cloud services, and it was actually more available for us to use. So, in our AI definition, basically, you usually hear about machine learning, you hear about deep learning, but those are all parts of the puzzle. So, if you look at this picture, machine learning itself is a one of the parts of the AI world, and deep learning itself is, again, a subset of machine learning. But if you look at it, you're going to hear actually about those 10 different building blocks of AI. And it's all completely fine. But sometimes you're going to use one in order to create another. So maybe you're going to use deep learning as part of machine learning to actually create some kind of cognitive understanding of the picture that is in front of you. So basically, those are interchangeable, and when people are talking about AI, they are talking about these 10 different building blocks. They're all currently are probably all in different stages of development. Some of them are already used in your regular day-to-day work. Some of them are in research. Some of them we are just thinking about. But those are the terms that are going to be relevant. If you look at the application of AI, I always like to divide it in 3 different things. Because there's pre-built AI. Pre-built AI is there for you to use. There's a knowledge engineering or knowledge mining process, which is a kind of somewhere in between the pre-built and custom AI. And there's, of course, custom AI. So we're going to explore all of those three with more, I would say, more accent on the latter one, on the custom AI. So pre-built AI. Pre-built AI services are something that you can explore for all three major cloud vendors. Whether you like AWS or Azure or GCP, they all have a set of pre-built AI services, which are kind of for, I don't know, decision-making, vision, language understanding, speech recognition, search, something like that. So that's built for you. Those models are trained for you. And they're given to you to use, and they're going to charge you per the number of requests or something like that for you to use in your apps. And that's completely fine. If you just need some kind of a general speech recognition or a general language understanding or whatever, for example, for a chatbot or some kind of virtual assistant that combines 2 or 3 or 4 different chatbots, that's completely okay. And that's why it's there. So this is aimed at developers. Nothing for you to do there, just to use these APIs. It works like it is. And there are scenarios, as I said, where you can actually employ those services immediately. You can use them. For example, RPA is quite popular now in all sorts of industries, the robotic process automation. And people always ask, what does that have to do with AI? And then I just say, all right, is part of robotic process automation to recognize what's on the screen? Yeah. Do you need to recognize all those different text box, option boxes, or whatever? Yeah. And how do you think that that is done? By an AI. Because one thing is if you have a simple Windows application that's using the operating system default, text boxes, check boxes, or whatever, then you can maybe go without AI. But if you are having a Java application or some kind of GDI plus application, you're not going to be able to do that. You'll require some kind of AI to actually recognize that that part of screen is a text box. So that's one of the applications of the pre-built AI scenario. Also, some kind of sentiment analysis in simple terms, speech recognition, as I mentioned before, intelligent agents or chatbots. Those are some of the examples where you can actually use what already there exists in the world of pre-built AI. Knowledge engineering is actually an extension of something we would call intelligent search. I always like to position knowledge engineering as a process where we get from unstructured data to a structured data, because that's basically what's happening behind. If you think about any kind of document that doesn't have a structure, it is text, it is OCR text or an actual text, doesn't matter. It doesn't have a structure. It's an unstructured data where a whole lot of valuable information actually lies. And we need to have a mechanism to actually extract that information from the unstructured data and make it somehow understandable and usable by our applications who are using structured data. And that's what we are doing actually by enabling the knowledge engineering in our scenarios. It basically looks like this. You have some kind of data sources, documents, invoices, whatever. You scan them, you OCR them, blah, blah, blah. You create something that's understandable to the computer, to the algorithm itself. Then you use some mechanisms which might come from pre-built AI, like, for example, Vision API to recognize what's in the image, language understanding to actually see what kind of intent is there in that particular paragraph of the text. And you build an index. You create this rich index of your documents. So it's not just going to be this document is talking about this and this, but it's also going to be on the pictures inside of these documents are these entities, these people, these buildings, these structures. So you're going to get a lot more information than just the ability to search through the text. And then you're going to build up an application that's going to ask that API in terms of queries, typical search queries, and actually get some data back. Many applications for this also, obviously, auditing and compliance is something that comes to mind because there are documents, there are contracts, invoices, blah, blah, blah. There's some data there. Auditing wants to know what's there, for example, for GDPR purposes. But there is also any kind of digital asset management that has an application. If you have tons of photos, tons of videos, you probably want to analyze them and structure them in some way that you can find where anything is. That's where the knowledge engineering actually comes to the point. So this is one of the cases where it was quite good, quite well applied, I would say. So it was a company that had a ton of agreements with the customers, and then they needed to extract some clauses from it. As you will see, it's, of course, related to the GDPR. And they used knowledge engineering. They used all sorts of cognitive services, cognitive skills, which we mentioned in a pre-built AI section, to actually go through those documents, to enrich their index, and actually enable their employees to get quick information for what kind of contracts they have signed with their customers in the past 10 years. What kind of important clauses are there for them to see and for them actually to explore. And this is just a little bit like a case study video. So basically, they had a set of contracts, they scanned it, they OCR'd it, and then they put them on some kind of storage. This is Azure logo. They told you that I used to work for Microsoft, so nothing else there to say. And basically, they went through the documents, recognized everything, translated it into English from French, for example. Then they detected the people that were in there, the entities that were in there, what else was mentioned there, all sorts of clauses. They even analyzed it for some particular reasons. So they actually extracted the clause that has something to do with GDPR. They detected the risk, and that's how they are actually serving it to their consumers, to the consumers of the content, basically, their internal employees, who can now do a quick search where else in the other documents is the same clause found. So this is the combination of the knowledge engineering process, in a process sense, of custom AI, which is the recognition of GDPR clause, for example, and the pre-built AI services, which are there for us to use. So the combination itself is actually how we got to the knowledge engineering in this particular case. And the last 25 minutes, 23 minutes, I'm going to spend talking about a custom AI, because that's probably the most interesting part in this whole story, because we are developers, you know, we want to actually work on something. This is for us to use. Let's build our own models. And that's basically what machine learning actually does. It finds patterns in the data. This implies that the data needs to have patterns. If the data doesn't have patterns, you're not going to find patterns in the data. I hope that's clear. Because I have business people coming to me, Tomislav, we want to do something with this data. We want to use it for machine learning purposes. And then we expect the data, and we say, guys, but this data can't be used for that. But that's data. We want to get insights into that data. But that data is useless for what you are trying to achieve. How is that possible? Well, you can't find patterns in data which doesn't have patterns. Period. Logical. So examples, detecting credit card frauds. Fraud detection in credit card business is something that's been with us for 20 years. More or less works the same today. There are better algorithms today, but it's more or less the same principle. Machine learning problem. Determining churn of a customer churn. That's typical machine learning problem. What actions did I take? So you've probably been part of this. Telecom companies typically do this. So somebody calls you, whether or not you're going to extend your agreement and blah, blah, blah. And then you say, I'm thinking about cancellation. Whoop, alert comes in. Oh, sir, we have a special package for you. You know, we're going to cut down the price for 50% for the next 6 months, and then you're going to get another phone or TV or laptop or whatever. So that's a really, really simple situation where you actually said that you're going to cancel. But they also have a way when you are saying no to first question, no to second question, no to third question. That basically means that you're reluctant to sign an agreement, and that's also going to trigger an alert, and then they're going to offer you an offer that you can't refuse. That's usually how this whole thing works. Also, maintenance is another story. So predictive maintenance is another machine learning problem. Recognizing traffic signs for the smart cars, road markings, typical machine learning problem, deep learning actually, as part of machine learning. Finding the best charging station for the car. This is something to think about. If we are going to get into the electric car business, then we're going to need to charge our electric cars. And then it might make sense to have some kind of smart system to actually be able, when we are driving down the highway, and it needs to know who else is driving, who else is going to need charging, and actually let us know, all right, if you go to this charging station, it's going to be the fastest, you're going to be second in a row, because I see one car ahead of you, so it's going to get charged first, and then you're going to get to the next point. Tesla has this implemented. That's just why I put it here. So there are many, many, many machine learning problems in the world. And that's what we can resolve by applying machine learning scenarios, machine learning algorithms. This is just one simple example. And each and every one of you can see it now immediately. So this is a simple example, and I ask you one simple question. Which of these transactions is actually fraudulent? What's the pattern? What's the pattern for the fraudulent transaction? This is stupid, so it's really simple. If a person has a name starting with a P, the transaction is fraudulent. That's obviously wrong, but that's what we can conclude out of this data we have. So typical answer would be, we need more data. This is obviously wrong. We can't just say whose ever surname starts with P and immediately decline the transaction. Obviously, not a good point. This is a bigger table. And now it becomes a little bit more complex for you to see the pattern. It's still possible. It's still not as complex as it usually is, because usually you're going to have thousands or 10,000s of rows, or maybe even hundreds of thousands, depending on what you are trying to predict. So this is doable, but it's already harder. So what would you do? If I would give you this data in Excel, you would do some kind of sorting. First, you would sort by one column, then by another column, then by a third column. And then at some point in time, you're going to see that there is a pattern. So if a person under 30 years old has a credit card that's issued in USA and used in Russia, and this is quite older than this last thing that's happening now in our neighborhood, so it has nothing to do with that. So under 30, card is issued in USA, used in Russia, and the amount is greater than $1,000, then the transaction is probably fraudulent. Way more complex than the first example. And that's what we do with machine learning. So we're going to apply different algorithms that's going to do that for us. I always like to explain it like sorting by this column, sorting by that column. So it's not just sorting. It's finding some kind of statistical relevance and everything else. But it's basically the same thing we would do manually. But computer does it for us 10 times, 20 times, 100 times faster. So in a nutshell, we have a data that actually has patterns. We apply algorithm that will find the patterns in that data which has patterns, and that's going to create a model. And then we're going to use that model which is able to recognize the pattern and feed it more data. We build an app that's going to call the model, and the model is going to return us some score. For example, whether or not this transaction is fraudulent. Model is never going to tell you yes or no. Model is going to tell you this is fraudulent 80%, 90%. It's going to be up to you to decide which level of confidence is okay that you think something is or isn't fraudulent. So why is machine learning so hot? Because machine learning actually requires three things: a load of data, a load of computer power, effective machine learning algorithms. Only those three things. And all three are now available more than ever in the history. Cheap computing power everywhere. Everybody tells you cheap servers here, cheap servers there. Microsoft tells you, come do machine learning here. AWS tells you, we have better machine learning system than Microsoft does. GCP tells you, we are the ones who invented the machine learning system, and blah, 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 and blah, 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 and blah, blah, blah. Everywhere the computing power. And that's why it's so hot. That's why it's doable now. Who is interested in machine learning? Everyone is interested in machine learning. They might not tell you that in that sense, but business leaders want to predict anything. They want to do forecasting. They want to stop the churn. They want to predict frauds. They want to all of that. They want immediately now. Developers want and like machine learning because they can build better applications, intelligent applications, more intelligent applications. And data scientists like machine learning because that's their job, basically. Prior to this point, they were only able to use statistical analysis tools, which is kind of some pre-process of the machine learning, data mining, something like that. But now they have better tools. They can actually apply the algorithms and let it run on thousands of servers. So something for what they needed, a specialized equipment, some kind of, Cray computer or something like that, is now doable from their own laptop by the power of the cloud. So that's why it's important for them now. Also, different vendors, I mentioned some of them. So these are cloud vendors who are doing something in this space and investing quite a lot. There are traditional analytics vendors there are some other traditional vendors in terms of data. Everybody's investing in this space. So it's actually quite important. What's important also, when you are approaching machine learning topic, is asking the right question. We heard this also in the architecture talk. It's quite important what you are trying to achieve. And it's always important. And it's even more important when you are approaching the machine learning. You need to choose the question which you are trying to answer. That's an example. Is this transaction fraudulent? You need to have the right data. As I mentioned before, if data doesn't have patterns, you're not going to find them there. And you need to be able to measure the success. You need to be able to measure. So that's what I said. Is 80% good enough? Is 90% good enough? For example, if you get an information that your credit card, that the potential transaction is actually fraudulent, with 85% of certainty, that's okay to actually trigger the process. Dear sir, please, can you confirm that this is your card, on the phone or something like that? That's okay. If you are going to diagnose a cancer and you get 85% of probability, is that okay? Would you tell a person with 85% probability to have a cancer? No, you wouldn't. Nobody would. You need more certainty, depending on the scenario. And that's something you need to decide at some point in time during the project. The process itself is iterative. And basically, the only thing why machine learning is kind of complex to understand is due to the fact that it's coming from the data science and not the developer world. Because some of the terminology for us developers is quite confusing. It's going to be really, really easy in a second. So basically, we have data. What we are doing with the data? We are preparing the data, which basically means we are processing the data. We are either cleansing the data, sorting the data differently, adding more data, connecting it in a relational sense. That means data processing. And there are data processing algorithms and models that are going to help us. And this process is iterative. Until we get the data in the format that we need, we're going to go through this iteration by applying different modules. We then have a prepared data. That basically means we have the data we're going to use for machine learning. That's prepared data, or training data, is it called. Then we are applying machine learning algorithms. We're going to see in a second what those are. So machine learning algorithms are actually looking at the data and creating a model. A model is a source code. Model is nothing but a code that's been created by the machine learning algorithm. And we're going to iterate through that process, because the first model that we create might not be the best model. We can include more data. We'll see in a second what we can do to get better models. At the end of the day, we're going to need to deploy the model. Deploying the model is also called inferencing the model. So if you heard about that term, that means get the model and deploy it somewhere that is reachable for our application. Usually that means deploy a container to Kubernetes cluster, usually. And then we're going to have an application that's going to be using that model. And this machine learning process is also repetitive on a long run, in a bigger picture, because reality changes. Back in 2020, early March, every machine learning model for forecasting fell, stopped, COVID hit, everything is changing. Every model needed to be recreated. But it's not always that on kind of, recreating on that level, because this changed the whole world. But your reality changes quite often, and you need to recreate your models maybe every 6 months, maybe every year, maybe every 2 weeks, depending on the reality you're working in. So I said about terminology. So there's training data, obviously. That's the data we prepare. That's training data. So if somebody comes to you, what's your training data? That means when we gathered all the data sources and actually put it in one table. It's obviously a table. It might have thousands, hundreds of thousands, or millions of rows and columns, but it's still a table. And then we use either supervised or unsupervised learning. So those are two terms. Supervised learning means that at the end of that table, there's an information that we are trying to predict. So if you looked at the data, whether or not transaction is fraudulent, you saw that I had yes, no, yes, no, yes, no, yes, no. That's a training data for supervised learning, because the information, what we are trying to predict, is actually present in the data. So we are going to train the model like that, and then we're going to let it work with a new set of data and kind of trying to predict that part of the data. So that's supervised learning. We have data, we have the value that we want to predict in our data, which means data is labeled. That's also another term. Unsupervised learning means that the value we are trying to predict is not in the data that we have. And you would ask, okay, why, what would we do with it? That basically means, the typical example is, for example, if you want to create a customer segments. You can't say, this is our customer segments, and then now, let's put some customers in those segments. You can, obviously, but that's an old way. New ways, these are all customers. Let the algorithm create clusters. And then we're going to see what our customer segments are. That information actually doesn't exist in the data. It's going to work itself up to us. Typical approach, obviously, is supervised learning, but there's also some usage, as I mentioned, in unsupervised. If we are using supervised learning, this is going to be another story about the terminology. We have data sources. We are using data preprocessing models, or some kind of software or whatever. We are creating the training data, and as I said, it's going to be a table. At the end of that table is going to be a value that we are trying to predict. These columns in these tables are called features. This is what stumbled me the most when I started working with machine learning 6 years ago, and I'm a developer by my habitus, as I like to say, and I was like, and somebody asked me, Tomislav, which features will you choose? What do you mean features? For me, a feature is some feature in the software. You know, it does this, it does that. No, no, no. In machine learning, the features are the columns in the training data. Why don't they call them columns? I don't know. They call them features, so just remember that. So features and the target value. That needs to be present in our training data in order to be able to use it for a supervised learning. I will just give you a few examples of the algorithms. I don't want to waste your time. This is also something that could take weeks to actually explain in detail. Regression is usually about predicting the value. So forecasting is a typical case when you are trying to predict, for example, how many items are going to get sold on that particular Friday. So that's going to give us some kind of number with some kind of certainty. Classification is going to get us whether or not this item belongs to class A or class B or class C. And I know that this might not come immediately to you, but our question, is this transaction fraudulent, is actually a classification problem. It's going to fall into yes and no classes. So that's when we use classification. But for example, for unsupervised learning, k-means approach, the k-means being like you have many dots and we are trying to kind of see which one are the closest, or you have a list of numbers and this algorithm is going to try to see which numbers kind of are closer together. For example, you have 1, 2, 3, then you have 10, 11, 12, and then you have 21, 22, 23. It's going to create three clusters because the first 3 are connected, the second 3 are close to each other, and the third 3 are close to each other. That's one example for creating customer segments. It's obviously going to be more complex than that, but that's what it is basically. There are also different styles. We mentioned regression. Decision trees quite well used in classification. Neural networks used by deep learning are kind of also here. That's one of the styles, more and more and more popular, especially in the last 3 to 5 years, actually. Bayesian approach, k-means, all sorts of styles of machine learning. Now I'm missing at least a few slides. Oh, come on. Until those lines come up, basically what I wanted to share with you, when you are using machine learning in order to create a model, that basically means that at the end of the day, you're going to get some kind of a source. So some kind of model is going to be deployed, and you're going to be using that model. And that is completely fine with most of the algorithms approach. For example, if you are taking typical forecasting situation, you're going to use regression. So you're going to have your algorithm probably in Python code or something like that. And when you create a model, that's going to be actually repeatable. However, if you are doing deep learning, you will also create a model. A model is going to be successful, but you will have no scientific explanation why it works. And although this is quite good for us to say we can't do that, it doesn't matter, it works. But think of the situation where it might matter. Okay, I'm going to skip this through because not to lose the time. This is basically about overfitting, underfitting the model. But what I wanted to tell you is this. The model sometimes needs to be explainable. And this is one of the situations where it actually got pretty scary. So we were trying to create an algorithm that's going to recognize a stop sign. We used machine learning, we used deep learning, and it was quite well. It was working. Smart car was driving. And then we said, all right, what if people put some kind of graffiti or something on that stop sign? Is it going to still work? And you wouldn't believe, for the situation number 1 and situation number 2, it was quite well. The computer was able to recognize that it's still a stop sign. And you would say, okay, that might confuse him. What about the third picture? He didn't recognize that as a stop sign at all, but a 45 miles per hour sign. You know what's happened here? There's a folly, a poster, transparent folly, over the sign. And it actually confused the machine learning algorithm to recognize this not as a stop sign, but as a 45 miles per hour sign. You know what would happen if that car actually got into traffic and didn't stop at the stop sign? Then somebody's going to ask, all right, let's go back to that company. How did you create this model? Oh, we use deep learning, neural network, blah, blah. But what's the process? How is the car deciding? Oh, it's all in the code. Where's the code? Okay. How is the car deciding? Oh, we don't know. There are just some pointers because basically deep learning is just total set of hundreds of thousands of pointers. That's how it works. But guys, what is the decision-making process? There isn't. It's not that kind of algorithm. So you can't explain why it doesn't work. It wasn't trained correctly. That's not an explanation. And that's going to be a problem. And it's not me telling you this. There are tons of research papers online that's speaking about this exact same problem. Many different cases, many different applications for the machine learning. I mentioned some of them already. They are all listed just here. Detecting credit card fraud is something that we spoke about quite a long time. We usually use historical transaction data. We know that some of that data, some of those transactions were fraudulent, and that's what we are using to train our applications. Also, predicting customer churn, a little bit more difficult problem, maybe. So we need more data. That data usually comes from different sources. Some of it is even unstructured data, for example, customer calls. And you are extracting that data to prepare it, to create the training data, and then again, the process is going to be the same. In your industry, typical connected car scenario, so I'm driving some car, for example, and I'm driving it 204 kilometers per hour on a highway in Croatia, which is not allowed, obviously. And then when I do that, a police could get an alert that I'm actually driving over the speed limit, and they can send a car to actually stop me at some point. Happened once or twice, I'm speaking from, but not like this, even though it could happen like this. Ultimate, last thing, equipment failure, and this is something that's going to be applicable for the future of your industry, because you're going to get tons of signals from the sensors inside of the car. You're going to have a powerful computer inside of it, and you will be able to do exact same thing as people are doing in the typical predictive maintenance manner. How to start with it? Basically, don't be afraid of the machine learning. If you're a developer, you're going to get to it. It's not that hard. It's not easy, but it's not that hard. You require a lot of data, obviously. You will require a lot of computing power, and you will require some kind of platform that's going to connect it all together. All of this is more available than ever. Welcome to the brave new world of artificial intelligence. Thank you.
So, thank you, Tomislav. It was very exciting to listen to you. I'm not one of the 3 C's, which already mentioned, but I could understand everything you were talking about. Thank you very much.
That was the goal.
Great. So, as we're running a little bit of time, and I have no online questions for you, but maybe the audience has a few questions. Yes, Mike. Karina is already running with the mic.
Hi, thanks for the presentation. My question is regarding the business users, right? You were saying they usually have so many requirements that they have no idea. How do you educate those people that you then translate those requirements into real solutions? Because usually, as you mentioned, they just come and say, I want to apply some magic AI, and in the end, all of my problems are solved. So how do you make sure that you bring them to some certain and concrete ideas, what they want to achieve?
I will explain to you one process that we are actually using. There are many different flavors, but what we did with one of the telcos operating in Croatia, basically part of Austrian Telecom and part of the worldwide telecom group, blah, blah, blah. They were actually asking the same questions. We always have some kind of initiatives in IT coming from the IT. We want different entities, different teams inside of the organization to bring the ideas. We organized a program. We were spending like 2 to 3 days of education, and the education was working like a set of case studies. So we were going through the practical examples, not talking about the technology, but what AI does, some examples from telco business, some examples outside of the telco business. We went them through the program. Then they were part of a group that needed to nominate the ideas that they would like to do. Again, there was some customer churn, obviously, and this and that and blah, blah, blah. And then we got those ideas, evaluated them, chose the top 15, and created 15 groups of people who always had somebody from marketing, somebody from HR, somebody from IT, somebody from sales, whatever. And they were spending 2 days on kind of, ideation workshop to actually get that idea from the question number 1, where is the data that you need? Regulation questions, can you use that data? How can you use it? Who you're going to need inside of organization to sponsor this, to the point to create a project for proposal that is going to go to the management board to actually get approved. A week work. So that's kind of a workshop that we did, that actually proved to us that it can be done. But they need to hear a lot of examples what AI can do, and then they need to be aware of their own environment, where the data actually resides and how they can use it and what they can achieve with it.
Okay, thank you.
Okay, so I would say, as we have only 10 minutes left for the break and until the third session, Tomislav is staying with us.
Yeah, I'm going to be here.
Everybody who has questions or is interested in this topic, please approach him, ask him. He will stay here with us, and you can all grab a coffee or a cake or something like that, and we will 10 minutes from now on, and then we'll start with the third session. Thank you very much.
Thank you.